If you're a developer, you know JSON. It's the language of the internet, the way we've been moving data around for decades. It's everywhere, in pretty much every API and application we build. But in this new age of AI, our old, trusted friend might have a secret, a very expensive secret. So we really have to ask this question. Is the one data format we all use day in and day out actually making our brand new AI apps slower and way more expensive than they need to be? Well, the answer is complicated, and honestly, it's pretty fascinating. All right, let's get right into it. The issue here isn't really with JSON itself. The problem is how large language models, LLMs, actually think about information. And it all boils down to this one little concept called tokens. So what's a token? You can think of it as the currency for an LLM. Every single time you send data to a model like GPT, and every time you get a response back, you're paying in tokens. And it's a simple equation. The more tokens you use, the more money it costs, and the longer you have to wait. This is just the perfect way to think about it. Imagine you're getting charged for every single character in a text message. Well, JSON is packed with extra characters, isn't it? You've got brackets, curly braces, commas, all those quotation marks. They're absolutely essential for structure, but for an LLM, they're just more tokens you have to pay for. And this slide just perfectly illustrates the problem. Take a look at this super simple object. In the world of LLMs, that opening curly brace, that's one token. Every single quote mark, that's another token. The comma, yep, that's a token too. All this syntax that machines need to understand JSON adds up, and it adds up fast. It's a significant overhead when you're literally paying by the piece. So as you can imagine, this exact problem got some people thinking there has to be a better way. And that's how a new format called TOON came about. It was built for one reason and one reason only, to say the exact same thing as JSON, but with way, way fewer tokens. So TOON, which stands for Token-Oriented Object Notation, is pretty clever. It gets sufficiency by kind of cherry-picking the best ideas from other formats we already know. It uses indentation for structure, kind of like YAML, and it uses a really compact row-based style, a bit like a CSV file. But here's the most important thing to remember. TOON is not trying to kill JSON. It's designed to be a specialized translation layer you use just when you're talking to an LLM. And this slide just shows you the whole philosophy in action. I mean, look at this. On the left, you've got JSON, with all its syntactic clutter, the brackets, the braces, the commas. On the right, you have the TOON version. It's structured, it's ordered, it communicates the exact same information, but it's so much cleaner to look at, and, most importantly, way more efficient with tokens. And that clean look, it translates into this absolutely massive number. In a lot of real-world scenarios, just converting your JSON data to TOON right before you send it to an LLM can slash your token count by 30 to 60%. That is a huge potential savings in both money and time. So the big question is, where do you get these incredible savings? Because, like any good tool, TOON has a very specific job it's amazing at, and that job is handling large, flat data structures. Let's look at a real test a developer ran. The task was simple. Send a list of 10 users to a GPT model. Using regular old JSON, the prompt came out to 757 tokens. But by taking a moment to encode that same data into TOON first, the prompt size plummeted to just 460 tokens. That's almost a 40% drop. And as a bonus, the TOON prompt was just way easier for a human to read. I mean, this chart really says it all, doesn't it? For this specific type of data, a simple flat list of objects, which, let's be honest, is super common, TOON is the hands-down winner. It's not even close. But, and this is where the story takes a really fascinating turn. We've seen TOON's superpower, but what about its kryptonite? What happens when our data stops being a nice, simple, flat list? So this is the crucial moment. When the same kind of test was run, but this time with deeply nested data, objects inside of other objects, the results did a complete 180. All of a sudden, TOON actually became less efficient than JSON. It ended up using more tokens than the format it was supposed to fix. So, what on earth is going on here? Well, it all comes down to a trade-off. See, JSON uses those brackets and braces to show how things are nested. TOML, on the other hand, uses repeated indentation, lots of spaces. When data gets really complex and deeply nested, the sheer number of spaces and special characters that TOML needs to describe that hierarchy can actually add up to more tokens than the simple brackets and braces of JSON. So, what's the big takeaway from all this? The conclusion is actually pretty clear. TOON isn't here to replace JSON. It's a specialized tool, and like any good tool, the secret is knowing exactly when to pull it out of your toolbox. This table right here is basically your cheat sheet. Are you about to send a big, flat list of things to an LLM? Use TOON, no question. You'll get maximum savings. But are you dealing with a messy, complex, deeply nested object? Stick with good old compacted JSON. It'll actually be more efficient. And for everything else, your normal APIs, your general app development, JSON is still king. Don't change a thing. So this is really the perfect workflow. You do not need to rewrite your apps or change your databases. Just keep building everything with JSON just like you always have. Then, at the very last second, right before you make that API call to an LLM, you just ask one simple question: is this data flat? If the answer is yes, you just run it through a quick TOON encoder and send the super efficient result. Think of it as an optimization step, not a replacement strategy. You know, TOON is fascinating because it only exists because LLMs created a totally new kind of problem that our old tools just weren't built to solve. And that really leaves us with a much bigger question to think about. As AI gets woven into everything we build, what other fundamental parts of our developer toolkit, things we take for granted like data formats or even programming languages, are we going to have to completely rethink and reinvent next?